Hello to everyone. I'd like to present you our topic, which is security of the sensory data in the cloud. Wireless sensor network contain many spatially distributed sensors that jointly monitor various environmental parameters. The amount of data generated by sensor networks is enormous, and therefore it requires significant hardware storage and computing power to store and process this data. While a sensor network has its limitations, resource limitations include short communication range and limited processing storage. Designing limitations depend on the type of the application. Designing an additional ability to process the collected data led to an increase in cost of the sensors. Cloud computing provides peak computing power and storage space. The integration between the cloud and the sensor network is a great solution to the problem of the limited computing power of the sensor network. The implementation of this integration has formed a new paradigm called sensor cloud computing. One of the most important barriers to cloud acceptance is security of data. Traditional security mechanisms are no longer satisfying for clouds in their current form. In this paper, we propose an algorithm to increase the security in the transmission of data from the sensor network to the cloud via SSL security protocol. Algorithm for securing transmitting sensor data in the cloud is shown in the figure and presents one of the options for securing the transmitted sensor data via TLC. These options include ThingSpin Cloud and an MQTT protocol. We create a stream that collects sensor data using no threat. The protection of the connection from the sensor network to the ThingSpeak is realized by generating a self-sync certificate with OpenSSL. To upload the sensor data, we select the ThingSpeak Cloud, which is an open platform for IoT data. ThingSpeak enables real-time data collection, analysis, and activation with the Open API for HTTP or MQTT protocol. With applications and plugins, there is the ability to store, visualize, monitor, and integrate user data with various third-party IoT platforms such as Arduino, RP, ThinkHTTP, MATLAB. Sensor data is collected in channels that can contain any type of data. MQTT protocol is designed mainly for connecting I/O devices with limited power over wireless network, and it's used for publish subscribing. MQTT is used to send short messages to and from the broker. ThingSpeak is used as an MQTT broker where that devices can send messages. ThingSpeak stores the message in channels where the data can be analyzed with MATLAB code. MQTT work with WebSockets and can be secure with SSL. MQTT support various mechanisms for data and security. There are three ways a broker can verify the identity of the MQTT client: client ID, username, password, client certificate. TLC can be used to protect the content of MQTT sensor data messages. Choosing a security protocol and hardware realization. First, we select an LP with a chip that allows us to store cryptographic keys. Once activated, Trusted Platform module provide full disk encryption and maintain a security mode of connecting an SSL socket for communication with the broker, ThinkPic, HTTP, and MQTT. Choosing a security protocol and hardware realization. Second, we use external hardware security module which use TCP IP and is added to the management system, generating stored cryptographic keys. We choose the transport layer security because it protects the transmitted data online between a web browser and a website via HTTPS and ensures that the data retains its original integrity and ensures confidentiality throughout encryption. We create a node-RED flow that gathers sensor data via texture sensors and functional node and pass it to ThingSpeak via MQTT node, which connects to the cloud and publishing the topic about the channel temperature humidity in our ThingSpeak channel. We secure the connection via SSL encryption, connecting to an MQTT using publish node. To connect to MQTT, we enter the IP and the port we are using. Security settings. We generate self-sync certificate with OpenSSL to protect the connection. For cloud protection, we use an username and MQTT API key, which are provided from ThingSpeak. To use the ThingSpeak TCP security, which changed the file protected port for MQTT to 808083. The monitoring of the sensor data in thick-speak MQTT is shown in the figure, the temperature and the humidity. Efficiency of the algorithm for data encryption was tested by Wireshark software for monitoring network protocols. The results are in the figure. Security socket layer contains TLC protocol and the application data protocol is MQTT. The integration between the clouds and the sensor network makes it possible to solve the problem of storing and processing big data. The biggest integration problem is the security of the sensor cloud connection. In this paper, we propose an algorithm that ensures security in the sensor cloud connection via TLC. The algorithm is implemented throughout the ThinkSpeak and the sensor cloud connection via MQTT, thus creating flow gathering sensor data using Node-RED and generate self-sync certificate with OpenSSL. The algorithm was tested with Wireshark, which confirmed that the data is encrypted via TLC. Thank you for the attention.